Welcome back, guys. In this lesson, we are going to help the camera follow Dave, even though he's really fast and so on. But yeah, the camera can do it. So let's trust her or trust it. I don't know. So yeah, let's first select our camera here. The first thing we want to do is bring it back a little bit. So for that, we are going to increase the size of the projection, of the orthographic projection actually. So let's set it to, let's say 9. Seems like a good value. All right, here we go. Then we can keep the near and far clipping planes as they are. No need to dive deeper in details in these ones. But what I want to do here is to change the color of the background. So I'm going to select environment here and set the background color to white. Here we go. That's way better. After that, we are going to create a new script that we are going to attach to our camera and move the camera along with Dave. Here we go. So right click, create a new C# script, camera controller. Here we go. Once it's compiled, we can grab it and attach it to our camera, like so. So I showed you the way where you could actually drag it and drop it inside of the inspector, like so. But you can also drag it and drop it inside of the game object in the hierarchy. So let's remove all of the other ones. We only do one camera controller and open it. Perfect. So we want the camera to follow the player. So we need... What do we need? A reference to the player, of course. So let's add that. Boom. Let's write serialize field, private, transform. So we need the transform component of the player because we want to follow or track its position. Player, or maybe target, just to make it more generic. Target. Then if we go back to Unity, we should have a target field right here. So let's wait. Yeah, perfect. Let's actually collapse the camera component, collapse the universal additional camera data, and specify Dave in our target. Cool. So right now, if we hit play, nothing will happen because we don't have any logic here. Then what we are going to do at start is simply follow Dave. And a good practice here when you want to follow something with the camera is not to put that inside of the update method. Actually, if you want to use physics, it's also a good practice not to put that in the update method, but in the fixed update method. So you know what? Let's do that. And just before that, let me explain quickly. I'm going to leave a link in the description here for that, but Unity has an execution order for all of its scripts and the methods inside of its scripts, okay? So you can spot the start method right here and the update method right here, okay? So we can already see that there is something before the start method that we can call, so reset, on enable, and awake. But in here, we are interested in the physics. Using rigidbody2d.velocity is using physics. Means using physics actually. So we need to run our physics inside of the fixed update instead of the update method. Okay, so this is for the game logic, ideally. And to follow stuff, you want to wait for them to move. So you first move your game objects and then you follow them. That's the core principle of following. So we need to use late update instead of the regular update. This is a quick thing. Again, it's important to know, even though that's not going to break your game if you put everything inside of the update method. But yeah, let's actually use good practices from the start. So let's go back to our script here. We want to put our physics inside of the fixed update method. So fixed update like so. Let's actually make it private, not private. Come on. Let's grab this and paste it here. We can remove it from here. Boom, remove the update method. And now we've got a clean script for the player controller. And of course, we're going to test that. So let's now go to camera controller and implement the late update like so. Perfect. We can actually remove the start and update method. And inside of here, what we're going to do is change the position of the camera. So we need to access what's the component that contains the position? Yep, the transform component. So transform.position equals, let's say, target.position. So we want to place our camera at the same position as our target. This is not going to work, but let's do it anyways. Let's hit play. And right now, the screen is blank and Dave has disappeared from the game view, but it's still in the scene view here. So what did happen here? We've got Dave at 0, 0, 0, and we've placed the camera at 0, 0, 0. So we can't spot Dave because we are actually at the same position. If we switch from 2D view to 3D view right here and press F to focus the camera, you can press multiple times actually to zoom in or zoom out. Let's hit pause and bring the camera back. Now if we bring it back, we can spot Dave, but if it's forward or in front of him, we won't be able to spot him. And we are placing it at the same position as Dave, so it's not going to be visible. If it's at 0, maybe if we set the near clipping plane to 0, we can spot Dave, but that's not optimal. So what we're going to do is use the same X and Y position, but keep the Z position at -10. So let's go back to our script here and create a new vector3 for the position. So a vector3 is simply a data structure with three values, the X, Y, and Z. So let's call it target position equals target.position. So we are creating a new vector3 and giving it the position of Dave's position. But we want to keep our current position along the z-axis. So target position.z to access the z value of our target position equals not 0 but -10 because we had -10 previously. Then we can move our camera, so transform that position to that specific position. Okay? I hope this is clear. If not, please leave a comment in the comment section. Now we're going to hit play and we should be good. So let's check. Yep, we are still at -10. And if we move, yeah, the camera is actually moving with Dave. So let's go back to 2D mode. You can click here, move Dave, and yep, the camera is following Dave perfectly. That is so cool. Okay, so that's one thing here. But it's still really weird because we can't spot that we can notice that Dave is working in the game view and we haven't clamped our camera position yet. So let's do that in the next one. See you there.